In this video, I want to show you how to do basic confidence interval calculations using R. Now, R is better suited to performing these confidence interval calculations when you're given a data set. So I'm going to go through a couple of different examples. The first one is related to the examples we see on the PDF sheet. The first one is going to be related to a data set where you're only told the sample statistics, the observed values. Now, unfortunately, in this sense, R can't do the calculations manually, which is a bit of a drag. So in this sense, what you need to do is input each of those pieces of information and manually build the upper and lower limits of the confidence interval. So for instance, in the IQ example, we have been given that the observed value has a sample mean of 105.84. So we can just type this in. The sample standard deviation is given as 15. So in this sense, R now recognizes each of these values, and you can use them as you need. Now, according to the formula that we've constructed for a confidence interval, what we need to do is come up with the critical values, the critical t values. And this is where we use the qt function, similar to q norm. Now, the statement of the problem that we've been given says we want a 98% confidence interval. So that means between the critical values, the positive and negative versions of the numbers, we want 98% of the area, or an area of 0.98. That also means that in each tail, we want an area of 0.01. And that's how I'm going to proceed in using the QT value. So I'm going to come up with this definition. I'll say that T is QT, and I want to use a total area of 0.99. What that means is I want the 99th percentile, so I only want 1% in that right tail area, and I have to tell it to use the proper degrees of freedom. So the degrees of freedom are always the sample size minus 1. So in our particular case, the degrees of freedom we have is 30. So typing this in is going to give us a critical value here, T, of 2.457 and some change. Now we've got these sample statistics input, the observed values, and now we begin the process of manually constructing the confidence intervals. So the lower limit is going to be the x bar value, subtract t times the standard deviation divided by the square root of our sample size. Now we could have defined a variable for the sample size here, n, but regardless, this is what we'll get. And you can see that we've spit out the lower value of our confidence interval. If I just do a few tweaks to the previous command and call this upper, this will create the upper limit. So it's a bit clunky and it's a bit awkward, but you can use R to construct everything. It's very similar to using a calculator. Now, R is much better suited to dealing with examples and building confidence intervals when you provide a data set. So the other example that I've given you on this PDF file is the red wine example. So in this sense, you can just copy and paste the values from the file and load them up into R. So I've done that, and I'm going to import it into R as a column, as a vector. Now, unfortunately, you need to separate things here by commas, so that's a little bit of manual work. But once you've done that, you can see that R registers this data set. There's a built-in command for confidence intervals and another item that's called a hypothesis test, and they're all in one. So we are going to use this function to construct a confidence interval. The command is t.test. And what you need to do is tell it which data set to use. So here I'm just going to call it Z. And then you need to tell it a confidence level. So conf.level, and this has to be a number between 0 and 1. Now, in our example for the red wine, we've got a confidence level of 90%. So when I type this in and hit enter, it's going to spit out a whole bunch of information. So the first lines where it says data, T equals DF, all of that stuff is not important to us. If we scroll down here to this bottom line, this is the confidence interval that we've been given. So this is a very, very straightforward way for us to calculate confidence intervals in R automatically. So it does prefer to have the data there. Now you can easily change the confidence level and spit out whatever you'd like, and it becomes a simple task.